Hi everyone, welcome to another video, and today we're going to be going through the topic of earthquakes and volcanoes, which is topic 2.1 in the natural environment. So firstly, we're going to be looking at the types of volcanoes there are, and there are two types you need to know, which are composite and shield. So we're going to go through composite first. So the characteristics of composite volcanoes you need to know is that they have steep sloping sides. And they also have sticky lava that runs along these steep slopes. So the lava here is sticky lava. And you also need to know that the explosions are more explosive. So more explosive volcanic eruptions. Alright, so that's what you need to know for composite volcanoes. For shield volcanoes, you need to know that the sides are gently sloping. So gently sloping sides. You also need to know that the lava that runs along these sides are thin and runny. So thin and runny lava. And also when it does erupt, the explosions are more gentle. So gentle eruptions. Okay, so that's all you need to know for the characteristics of these two types of volcanoes. And next we're going to be looking at the general features of a volcano. So we're going to start from the bottom. So the bottom here, this is called the magma chamber. And this is where all the magma is stored within the volcano. And the red bits, by the way, are magma. And then you have this main vent going up to the crater. So we can label this here main vent. And this little hollow bit here at the top is called the crater. And this is where volcanic bombs and eruptions take place. You also need to know these little holes that come out from the side of the volcano, and these are called parasitic cones, and they're separate from the main crater. And finally, you need to know that these layers here are all ash. So the line separating them, so layers of ash. And you also need to know that when magma exits the volcano, it's now referred to as lava. So it's important not to get these two mixed up. So magma is when you're referring to when it's inside the volcano, and lava is when it's outside the volcano. So yeah. Next we're going to be looking at the features of an earthquake. So here we have the fault, and this is a crack between two sections of rock, as you can see here with this thick black line. Next is the focus, which is the point at which earthquakes occur. And you can see that there are waves, and these are called seismic waves, and they're released from the focus, and these are what cause earthquakes. And the epicenter of an earthquake is the point directly above the focus. Okay, so that's all you need to know for features of an earthquake. Next, we're going to be looking at the distribution of earthquakes and volcanoes. Now, you don't need to know the specific plates and what their names are. All you need to know is that earthquakes and volcanoes are often occur on plate boundaries. So these are these white lines here that span across the globe. And this is where and as you get closer to these lines, the frequency of earthquakes and volcanoes will increase. Okay, so now we're going to be looking at the types of plate boundaries that cause earthquakes and volcanoes. So the first one is a constructive plate, and this usually occurs between two oceanic plates. So basically what happens is that these plates move away from each other, as you can see by these arrows here in the sea, and this causes the magma to be exposed. So these red dashes here, this is the magma being exposed, and this allows the magma to erupt into a volcano, so it'll come out as lava. So at this plate boundary, both earthquakes and volcanoes can occur. Alright, so now we're going to be moving to destructive plate boundaries. And by the way, the names in brackets are what they could be referred to as well in the exam. So these terms can be used interchangeably. So constructive is the same as divergent, and destructive is the same as convergent. So if you see the convergence of destructive, just know that they're referring to a destructive plate. Anyway, so destructive involves a continental and an oceanic plate, as you can see in the image. And basically what happens is that when these plates approach each other, because the oceanic plate is more dense, it subducts under the continental plate. So ocean plate is more dense, so it subducts. And as it subducts, the friction between the two plates that occur around this area here causes the oceanic plate to melt into magma. So oceanic plate melts into magma. And as the oceanic plate melts, this builds up the amount of magma in the crust, and this causes the pressure to increase on the continental crust. So this magma will slowly rise as it occupies volume. And eventually the magma bursts through the surface, as you can see here, through the volcano. And this causes a very explosive eruption. So yeah, that's all you need to know for a destructive plate boundary. Okay, so the next plate boundary you need to know is collisions, and these involve two land plates. Also, I forgot to mention in this one, both earthquakes and volcanoes can occur here. Alright. So now we're going to be going back to collision plates. So these involve two land plates moving towards each other. And when they move towards each other, because they have the same density, the land is pushed upwards, as you can see with these ridges here. And apparently it'll be pushed upwards to the point where it forms these fold mountains. So that it kind of looks like this, like a mountain range. Like for example, the Himalayas were formed as a result of collision between the Indian plate and the Eurasian plate. So this caused the fold mountains to form. And mainly earthquakes occur here. Many earthquakes occur here. Okay, so next we're going to be looking at a conservative plate boundary, and these usually involve two land plates. And these plates can either be moving in opposite directions, as you can see in the diagram, or they can be moving in the same direction. However, if it does move in the same direction, it has to be at different speeds. So as these plates slide past each other, they will eventually lock together due to like a irregularity in the plates. So locks together. And this causes the buildup of pressure. And eventually this pressure causes an earthquake to occur. So only earthquakes occur at these plate boundaries. Alright, so those are all you need to know for the 4 types of plate boundaries, and now we're going to be looking at the more human side of volcanoes, so the effects of it and the opportunities it provides, as well as solutions for managing these events. So first we'll be looking at the effects of earthquakes and volcanic eruptions on the environment. So this can cause a loss of biodiversity, and this is because the habitats of different species may be destroyed in the event of an earthquake or a volcanic eruption. So this causes the biodiversity to decrease. The next thing is it can cause wildfires, especially in the case of volcanoes, because if lava flows into forests, it can set the trees up in fire. So this allows a wildfire to quickly spread. It can also cause landslides because of the plates moving. So the land on the surface could become unstable, and therefore there could be landslides, which could also destroy the environment. There also may be the release of toxic gases like sulfur dioxide and nitrogen dioxide as a result of the ash flows from volcanic eruptions, and these could be poisonous and could lead to the death of both animals and humans who live in the vicinity of the volcano. And finally, it can also cause mud flows, and this is because the surface may liquefy, so it may behave like a liquid, which causes mud to flow easier. So now we're going to be looking at the effects of earthquakes and volcanic eruptions on people. So the quite obvious one is death/injury. And this is because earthquakes and volcanic eruptions are hazardous events to people, and it could lead to the destruction of, say, for buildings, or it can lead to landslides, which could cause casualties. Secondly, it can cause transport disruptions, and this could result in aid not being able to be transferred to areas which are in need of humanitarian aid after an event like an earthquake or volcano. The next thing is the destruction of infrastructure, and this can lower the economy of the local area, because they won't be able to like produce and make goods and services, and therefore it could cause an economic decline in the local area. It can also cause power cuts because the national grids that span across the area or the country or the area where the event is taking place, it can cause the power lines to be destroyed. So therefore, there may be blackouts in different settlements within the area. And finally, airports may close. And this is because it may be too unsafe for aircraft to safely take off and land. And therefore, it can decrease the amount of tourism in the area where the volcanic eruption or earthquake happened. So it could also negatively impact the economy. So now we're going to be looking at the opportunities of living near volcanoes. So the first opportunity is geothermal power. And this is because within the vicinity of volcanoes, there are hot springs underground, which can be used for generating power in the form of geothermal power. The next thing is fertile soils. And this is because there may be a lot of minerals within the soil of the volcano. So this can increase agriculture and therefore improve income for those living near volcanoes. The next is tourism. And this is because volcanoes are quite rare structures on the earth. So this will drag tourists to come and visit these marvels. So this could also increase the economy in the local area where the volcanoes are. The next thing is mining, because as I mentioned with fertile soils, there are a lot of minerals which can be mined out of areas near volcanoes, and these could be used for selling or just manufacturing goods, I guess. So this can also benefit the economy in the area. And they can also create new land area for humans to settle in, and this can decrease the stress on maybe a heavily densely populated area, and can therefore alleviate the stress on that area as people can have the opportunity to move to a new area. Anyways, that's all for the opportunities of living near volcanoes. And now we're going to be looking at mitigation strategies against earthquakes. So the first one is to implement warning systems. And this is because when these warning systems sound, then people will know how to react and what procedures that they should take to decrease their risk of harm from earthquakes. The next thing they could do is education. So what I mean by this is educating people about what to do in an earthquake. So again, they can take the necessary precautions to prevent from themselves getting injured or in trouble. Another mitigation strategy is to have humanitarian aid on standby, so that if the earthquake does happen, then humanitarian aid can be accessed easily, and therefore there may be less casualties. Accessible. Okay. There should also be shatterproof glass for windows in buildings. So, and this is good because if an earthquake does happen, it decreases the chance of injury of those who aren't able to get away from an area of glass or a window. So it can reduce the casualties in the event of an earthquake. And finally, reinforce buildings with concrete. And this can also help with reducing the amount of casualties in an earthquake, because by reinforcing buildings, they're less likely to collapse, and therefore it will protect the lives of those that are inside the building. Okay, so next we're going to be looking at mitigation strategies for volcanoes. So one is to create diversion channels of lava. And what this allows is for lava to be transported away from the urban areas where there are lots of people, and therefore there will be less casualties. Again, for volcanoes, there should be education. So it will be good to educate people on the procedures that they should take place if the volcano does erupt in their area. The next thing is to monitor volcanic activity. And this is because mitigation strategies can be put in place if they can predict when a volcano will erupt, and therefore people will be more prepared to deal with the volcano, and therefore it will decrease the casualties caused by the eruption. Finally, they should also an exclusion zone should also be created around the volcano because it can also decrease the casualties in the area, as the volcano might potentially impact a certain area. So by moving people away from that area will decrease their chance of being in danger by volcano. And finally, evacuation is a good mitigation strategy. So moving people out of the area which is potentially in danger. So this decreases the casualties caused by a volcanic eruption. Okay, so now we're going to be looking at the case studies that you need to know for this topic. So the first one you need to know is an example of an earthquake. So this can be any event in recent times. So you should include 3 place-specific information about the cause of an earthquake. So in reference to the plate boundaries we've been discussing earlier, you should be looking for place-specific information to do with that plate boundary. You could say something like, oh, maybe in the Takuku earthquake, the oceanic plate was moving at a rate of 9 centimeters per year closer to the Eurasian plate. So that's an example of a place-specific information that you could use. You should also include 3 effects of the event on both the people and the environment. And you should also include 3 solutions. So that means the mitigation strategies to reduce the impacts of earthquakes. So you also need to know an example of a volcano, and you need to know the place-specific information about the plate boundaries, so the cause. 3 effects of the volcanic eruption. You should also know 3 opportunities that living near that specific volcano can provide for people living there. And you also should know 3 solutions to combat the effect of a volcanic eruption. Anyways, that's it for today, and I hope you found this video helpful, and bye.